Welcome back. In this video, we are going to learn how to graph an absolute value function. So an absolute value function can look like this: y equals, or f of x equals, the absolute value of x. So absolute value, it's always a positive number because it's a distance from 0 and distance is positive. So we're going to learn how to graph things like this. So the general form of an absolute value function. First, we need to know what an absolute value equation can look like. So in function notation, it's f of x equals a number, we'll call it a, times the absolute value of x minus h plus k. So this is the general form. So some things about this. One is I can very quickly identify if this absolute value should open up or down. What do I mean by open up or down? When we graph an absolute value function, it's going to make a V. And it can open up or it can open down. When I look at A, I know immediately if it opens up or down. So a positive A means it opens up, and a negative A means it opens down. Okay, so graph like this, A would be positive. A graph like this, A would be negative. Okay, now in order to graph it, a couple things we need. One is a vertex. The vertex would be this point right here or this point right here. The vertex is hk. Okay, now this right here is negative h, or the opposite of h. So whatever is here, the opposite number goes here. Plus k means we keep it as it is. So the opposite of this number, and then exactly this number gives you the vertex. There's something else that a tells us that we need in order to graph. A is the slope to the right side of the vertex. And the opposite of A is the slope on the left side. Okay, so here we have what's called the parent function, which means there's no transformations. It's not going to shift up or down. It's not going to open wider or narrower or taller or shorter. So the vertex here is going to be 0, 0, because there's no h, there's no k, so that's 0. A is 1, and it's positive 1, which tells me immediately once I graph this, I know it needs to open upward. So the slope on the right side is 1. Okay, so I'm going to make a note here that the slope is 1 on the right side, and the slope is going to be the opposite of 1 on the left side. Now I'm going to put that in more mathematical notation here. So we'll name the domain where the slope is 1 and the domain where the slope is negative 1. So the slope is 1 for x's that are to the right of the vertex, so greater than 0. And the slope is negative 1 for x's that are to the left of the vertex, so less than 0. So the vertex is 0, 0. And on the right side, there's a slope of 1, which means up 1 and right 1. And I'll do as many of those as I can. So here is the right side of the graph. The slope is negative 1 on the left side. Now look, like negative 1, sometimes we want to go down and right. But if I do that, it's not opening up, is it? It's the bottom half of something that opens to the right. But it should be the left half of something that opens up. So we're going to go up and left to get that negative 1 slope. Up 1 and left 1 as many times as I can. Gives me a slope of negative 1 on the left side of my graph. And there is the graph of the parent function, y equals the absolute value of x. Now we're going to start to include some transformations. So here we have a slope of 1 again. A is 1, and that tells me it better open up when we're finished. The vertex is the opposite of what's here. So this is the opposite of h, which means h is positive 4. And here's k, 3. I only have to change the sign on that number right there. Okay, so the vertex is 4, 3. So let's graph that. So there's my vertex. Now, the slope. The slope is 1 on the right side. So for x's that are right of the vertex means greater than 4. So for x is greater than 4, we've got a slope of 1. So there is the right side. The slope is negative 1 to the left of the vertex. So that's for x's that are less than 4. Negative 1, and I wrote a 1 there, so let's fix that. Negative 1 means up and left. And there is the left side of the graph. Okay, here we have a negative 1 for A, which means that this one is going to open downward. The vertex, there's nothing in here for h, so the vertex is 0, and then k is negative 3. The slope is negative 1 on the right side, so for x is to the right of 0, and the slope is the opposite of that, positive 1, for x's that are to the left of or less than 0. So we have 0, negative 3, and then on the right side, I've got a slope of negative 1, so down 1 and right 1. And there's my slope of negative 1. So here is the right side of the graph. Then on the left side, I have a slope of positive 1. And usually that means we want to go up and right. But if I'm going up and right, I'm opening to the right. I'm not opening down. So instead of up and right, we'll do a double negative, down and left. And a double negative gives us a positive. So down and left gives us our slope of positive 1, and there is the left side of the graph. Okay, we'll turn this over and do 2 more. Okay, so here, A is 1/2. It's positive, so I know this one is going to have to open up. The vertex opposite of h is right here. The opposite of h is 2, which means h is negative 2. And k is also negative 2. Negative 2, negative 2. Marked the wrong spot there. I'm going to go down another one. There we go. There's my vertex. We'll just ignore that spot right there. And then the slope is 1/2 on the right side. So A is 1/2, so slope is 1/2 for x's that are to the right of or greater than negative 2. And on the left side, the slope is negative 1/2. So that's for x's that are to the left of or less than the vertex, negative 2. So on the right side, we've got a slope of 1/2. So that's up 1 and right 2. And again, up 1 and right 2, as many times as I can fit. There is the right side of my graph. Then the slope is negative 1/2. So instead of up and right, let's go up and left. Up 1 and left 2. And there's the left side of my graph, and I have a V that opens upward. And this last one is going to open downward because A is negative. The vertex is positive 1, so there's the opposite of H. So H is 1, K is 3. So 1, 3. There's the vertex. The slope on the right side is negative 3, so that is negative 3 for x's that are greater than the x value of the vertex, 1. And the slope on the left side is going to be the opposite. It's going to be positive 3 for the left side, so for x's that are to the left of or less than 1. Okay, so on the right side, negative 3, so that's down 3 and right 1. As many times as we can. So there is the right side of the graph. And on the left side, it's positive 3. So instead of going up 3 and right 1, we want to make sure it opens downward. So we'll go down 3 and left 1, and it's opening downward. There is the left side of my graph.